Hello everybody and welcome to a bonus practice video. So what I wanted to do here is to basically walk you through what it would take to solve one of these from start to finish. Just doing it, for practice as an example. So I put together one right here. I haven't crunched any of these numbers though. The only thing that I've done actually is I did double check to make sure that these means don't have decimals on them, just so that would be a little bit faster and a little bit easier calculating these. But other than that, I haven't run any of these stats, so I do not know what the outcome is going to be. So we can find out together. So what I would like for you to do is to take this information that you see right here and everything that you've learned in the previous video for chapter 10 and try to solve it on your own. See how far you can get before you have to pause and kind of watch the video a little bit to kind of jog your memory, and just see how much you can do solo on your own before you start writing down what I write down. Okay, so here we go. And of course I have to. Can I change my pointer? Yeah, I'm going to change into blue ink. Alright, so let's get into it. So I predict early classes have higher exam scores compared to later classes in the day. This is 8:15 versus 3:45. When I first started working at Westfield, I had a lot of afternoon classes, but I really like teaching in the morning, so that's why a lot of my classes begin at either at 8:15 or 9:20. So I had the suspicion, and the reason why I had the suspicion is because I think that the overachievers are the ones who have all these early classes. So that's why I think they have a higher exam scores. So we can find out though. So the first thing that I want to do is I'm going to go ahead and do the hypothesis piece to this first. So what is the hypothesis? So you know that I can go ahead and write out HO and HA. And I'm going to start with HA, with my alternative hypothesis. I look up here, I predict early classes have higher exam scores compared to later classes. So I know there's some direction here, that there is directionality. So it's not going to be a two-tailed test, it's going to be a one-tailed test. And so I'm seeing this, and I'm going to go ahead and write out the mean 1, mean 2, and mean 1 up here, and mean 2 over here. And what I'm seeing is that group 1, so the early class, is going to be greater than the second class, and the opposite of that for the null is just going to be less than or equal to. So again, I started out with the alternative hypothesis. I established that I'm predicting these values to have larger values, and that makes it greater than, and then I'm just doing whatever the opposite is for the null hypothesis, which is less than or equal to. Alright, so alright, we're already done. We're making good time. What about the critical value? So what do we need for the critical value? Do you remember? What was it that we needed? We needed the alpha value, which is going to be 0.05. It always is. And we need the degrees of freedom for 1 and for 2. Remember? Because this is a little bit different now. So we need the degrees of freedom for both. So I'm looking up here. That's 1, 2, 3, 4, 5, 6. 6 people. 6 minus 1. Be equal to 5. Here, 1, 2, 3, 4, 5, 6, 7. 7 minus 1 is equal to 6. Now, one thing I haven't mentioned yet. You see that these two have different sample sizes. The only way you're able to do a t-test on that is if you do independent samples. So another way to double check your work is that if you find that these samples are not equal sizes, you're never going to do a paired samples t-test. You can't do it. So we're doing independent samples here. Alright, so my degrees of freedom is going to be 11, right? Because I'm adding these two up, and that gives me degrees of freedom of 11. Another way that I could have done that is I could have just added 7 and 6, and that gives me 13 minus 2, and that's going to give me 11. Either way, 11 is the degrees of freedom that we need. So I'm going to pop over here to... you can see I had the highest grossing movies of the 2010s up because I was going to try to come up with an example with that, but it was way too much work. so I bailed on that. So I'm going to do a one-tailed test, and my degrees of freedom is 11. Oops, sorry, I typed in the wrong number for the significance level. It should be 0.05. And that gives me 1.79. So 1.79. Now I'm going to come back over here. And I'm going to go ahead and draw my distribution. I'm going to draw it down here, I think. I think it's safe to draw it down here, of what I'm expecting to find. So I got my distribution. I'm just making the little tick marks now. And so I'm putting that 1.79, so basically 1.8. I'm going to be putting that right here. And you may ask, why did I put it here and not down there? The reason why is because I'm looking for greater than, so I'm looking for positive change. And so for that reason, I'm going to be looking for values in this part of the curve. So the t-critical is going to be plus 1.8, positive 1.8. All right, so now is the fun part. Now we get to do the test statistics. So the way that we do this is we're going to essentially get the standard deviation, or almost the standard deviation for each of these. We can stop once we get the sum of squares. So we're going to do that for this. I did not give myself enough room to write this out here, so I'm actually going to recopy it just to give myself a little bit of room. So I'm going to put that right about here. So 3:45 p.m. and you'll see why I'm giving myself some room like this, because I'm going to do the same thing for both groups. And so it'll be very cluttered if I did not make them far apart like this. All right. Let me put this back in blue. Okay. All right, so the first thing I'm going to do is I'm going to do this all for the first sample, and then I'm going to do it all for the second sample. So for the first sample, I need to find the mean, right? So I need to find out what x bar is. X bar, I'm going to be adding up 100, 90, 65, 76, 70, and 85. And then I'm going to be dividing that by 6, because I have 6 people, and that gives me a mean of 81. I'm going to pop over here, and I'm going to do the same thing. Yeah, initially I was going to do all this together, but I'm going to do them simultaneously, just to kind of try something new. So I'm going to add all these together, get the mean for that. So 60 plus 70 plus 80 plus 85 plus 90 plus 83 plus 78 is going to give me 546. Then divide that by 7, and that gives me 78. Okay. And we can't stop here. We want to solve this question up here. I predict early classes have higher exam scores, and I can't do that just with these numbers. If I do just those numbers, that doesn't take into account the variability of the scores that we have here or the sample size. So we have to ultimately get the test statistic here. That's why we can't just eyeball it, even though it does seem like our 815 has higher grades. So I'm going to be now subtracting each of these by the mean. That's going to give me my residuals. So 100 subtracted by 81, 90 subtracted by 81, so on and so forth. I'm just doing all these out here so it can be as clear as possible. Whoops, I was putting 81 there. That is not correct. It should be 78. So I'm putting all these 78s here because I'm going to subtract those from my residuals. All right, so this is going to be 19. This is going to be 9. This is I don't trust myself to do negatives off the top of my head. So that's going to be negative 16. 76 subtracted by 81. It's going to be negative 5. 70 subtracted by 81 is going to be negative 11. And then positive 4. And y'all know me, I'm going to add these together to make sure that I get 0. And I do. So I know I'm on the right track for this. Now it's time to come over here and do the same thing over here. So again, I'm going to do 60 subtracted by the mean. It's going to be negative 18. This is going to be negative 8. This is going to be 2. This is going to be 7. This is going to be 12. This is going to be 5, and that's going to be 0. Let me double check, make sure that those add up to 0. Ooh, oh, I typed in the wrong number. Yes, it does give me 0. Great. All right. Now, I'm going to be squaring each of these. So it's time to square them, right? So let's do that. So 19 times 19. I wish I could do that off the top of my head. That is 361 plus 81, because 9 times 9 is 31. So 16 times 16 is 256. This is 25, 121, and 16. Then moving over here, that's going to be 18 times 18 is 324. 8 times 8 is 64. 2 times 2 is 4. 7 times 7 is 49. 144 and 25. Great. Now I can add these together. So let's add these together. That's going to give me 361 plus 81 plus 256 plus 25 plus 121 plus 16. That gives me sum of squares for the first group is going to be equal to 860. Now moving over here, I'm going to do that same thing. So 324 plus 64 plus 4 plus 49 plus 144 plus 25 is going to give me 610. And that's going to be the sum of squares for group number 2. All right. Okay, so now we can refer to our, remember we have a couple of slightly different formulas here. So we're going to be doing this one first. And that one is going to be, if I remember correctly off the top of my head, this is going to be this. I'm just going to double check that just to make sure. Okay, I got it right. Just making sure. Because I can't tell you how upsetting it is to get this wrong and then just calculate everything and then you find out that like everything is wrong because you flubbed the formula. So that's going to equal for us, it's going to be 860 plus 610. I'm going to make that a little more clear. Degrees of freedom here is going to be 5 plus 6. So that's going to give me 860 plus 610 is equal to 1470 divided by 11. And that gives me 133.64. All right, so that is my value right here. So I'm just going to make a note of that too, because I'm going to be using this value again once I do my effect size. So I'm sticking that right there. All right, now we have another piece because now we want to calculate this, the standard error or the standard pooled error, and that one is, if I remember correctly, is this. And excuse me, I'm just going to double check. Yep, that's correct. So I have all these values. I can plug those in. So it's going to be the square root of 133.64 divided by the n of 1, which is 6, plus the same thing, 133.64 divided by the total sample size here, which is 7. And what will that give me? This is going to be a really gnarly number. Alright, so it's going to be the square root of 22.27 plus, oops, 19.09, which is going to be equal to the square root of 41.36. That's going to be equal to 6.43. All right, so that is our pooled error. Congratulations, folks. We are almost home. So now we want to find our t-obtained value, and that is going to be equal to the mean of the first group subtracted by the mean of the second group divided by the standard error. And we know all those values, so x bar 1 is going to be 81. Subtracted by x bar 2, which is 78, divided by the standard error, which is 6.43. That's going to give me 3 divided by 6.43, which is going to give me a low value, 0.47 when I round up. Wow, that's much lower than I thought it was going to be, actually. So my test statistic, my t-obtained value, is going to be equal to 0.47. All right, so where does 0.47 fit in here? That is going to land like right here. In other words, we fail to reject the null. So when we make our decision, we're going to say that we fail to reject. All right. And so if we wanted to put that into APA, how we would say that. I'm going to leave off the paragraph piece just because there's not really enough room for that here. But it would be basically T and then the total degrees of freedom, right, which is 11 when I add those degrees of freedom up. So T11 is going to be equal to 0.47, and then P is going to be greater than 0.5 because I failed to reject the null. All right, we are almost done. Let's do the confidence interval now in the space that we have left. So the confidence interval, I'll do it right here, I think. The confidence interval is going to, for a 95% confidence interval, because that's what our alpha value is 0.05. 0.05. That's going to be equal to x bar 1 subtracted by x bar 2 plus and minus t critical multiplied by the standard error. Okay, so we have all those ingredients. Now it's just a matter of plugging them in. So we know that x bar 1 is going to be 81 subtracted by 78 plus and minus t critical, which is 1.8, and then we're going to multiply that by the pooled error. The pooled error, which is, where did I put it? Yeah, this 6.3. All right, so that's going to give me 3 plus and minus 1.8 times 6.43, which I'm getting as 11.57, which means that this is going to give me, in my lower bound, it's going to give me, so 3 subtracted by 11.57 is going to give me negative 8.57. And it's going to give me a positive 14.57. Is that right? Let me double check that. I have concerns. No, I guess that's right. Okay. So that is that right? Yeah, okay. All right, so whenever I look at this, again, 0 does fall within that band, which reiterates that we made the correct choice in failing to reject the null, because 0 does fall in that interval. That is our confidence interval for 95% confidence. So we are 95% confident that the true mean difference between sample 1 and sample 2 is somewhere between these values. That's what that means. And then finally, we're going to be moving over to the effect size. And the effect size is going to be this, x bar 1 minus x bar 2 divided by the square root of the pooled variance. So it's a slightly different denominator. But we already have most of these pieces. So that's going to be, Cohen's d is going to be equal to 81 subtracted by 78 divided by the square root of, what is the pooled variance? That's 133.64. It's going to be 3 divided by the square root of 133.64, and that is going to give me, sorry, I'm just going to get the denominator first. It's going to be 11.56, which is going to be equal to 0.26 or somewhere there about. So if this were a significant difference, if we did fail to reject the null, then we would say that it's a pretty small effect size. It's not a big effect size by any means. But we can't even really say that because we failed to reject the null, so it wouldn't be fair to say that it causes an effect, because failing to reject the null means that we found no effect to begin with. So that's pretty much it. That is solving this from scratch, how to do that on an exam. So thank you so much for tuning in. If you have any questions about this at all, feel free to let me know. Otherwise, I wish you the best of luck in all of your adventures. And sorry, I'm just stalling a little bit because I didn't write this out next to where I thought that I would. So there we go. All right. Thank you, everybody. See you later.